Welcome, geometry students, to class today on this Tuesday, the 21st. Hope you guys are ready to learn some math today. Hope you're doing well. Hope that you enjoyed your 3-day weekend. I know that I did, and I hope that you guys did also. Please work hard in class today. Your education is very important. Some of you might love this class. Some of you might, hate it, strongly dislike it, but please work hard. It's so important that you do that, okay, guys? Please work hard. Please contact me, email me, or call me if I can help you in any way at all. Okay, I'm back. Sorry about that. One of my children was yelling for me. Sorry about that. Okay, please work hard and call me or email me if I can help you at all. There will be a test on Friday. I'm going to try to be there. I think there's a pretty good chance I will be. Turn in homework from over the weekend. Jake, now Jake, you've done great, and you're not behind at all. But the other 3 students turned theirs in Friday, which you did not have to do. Okay, that's fine. But yours is due today, so please turn yours in. Now, Haley, you have to turn in your weekend from over the homework, but also basically it was the 2 assignments. So you emailed me, and by the way, Haley was a little behind. It was not her fault. There was a quiz mix-up. The teacher did not have the quiz. She went to try to find the quiz last week. She couldn't find the teacher, etc., etc. So Haley, you're totally fine. But if I don't have all those turned in today, I will have to email your parents or call them. So I will be looking for these later on today when I pick up my son from school, or probably when I come to the games tonight. Now, so Haley, you owed me 2 assignments. So this homework from over the weekend, just so you know, Haley, that was part of the 2 assignments. So please don't think that you owe me 2 assignments plus the one from over the weekend. That's not the case, okay? You emailed me last week and you said, Mr. Earhart, here's the 2 assignments I'm behind on. And I emailed you back and I said, yes, you're correct. That does include this one right here, so don't worry about this, okay? You just turn in these 2 and you'll be totally caught up. There's a good chance you won't finish the video in class today. Don't be upset about that. You have no homework. Oh, by the way, the assignment you're supposed to turn in is down here. Sorry about that. Jake and Haley. Haley, this is one of your 2 assignments right here. Jake, this is the one you're supposed to turn in right here. Okay? All right. There's no homework tonight. This is a very long lesson. You might be able to finish in class. It'll be close. But if you don't, you are to finish it tonight. Well, Mr. Arthur, that's not fair. It's just like doing homework. I mean, if I give you homework in class, you're supposed to go home and do it. If I tell you to finish, if I made you finish the video and then gave you homework on top of that, I can see that's a little extreme. But tomorrow when you come in, you're going to work on a bunch of homework tomorrow. Today we're just taking notes for a very long time, and then if you don't finish the video in class, I want you to go home and finish it. Let me get a quick drink here. Okay, let's start by going over your quizzes. Remember my philosophy. I go fast, and you need to pause the video. You'll pause the video a lot today, and that's normal, okay? I don't wait for you to copy things down because I don't know how long to wait. Some of you are quicker, some of you are slower, and so I just go and you pause it at your own pace. Okay, let's start by going over your quizzes. Please get out your quizzes and turn in your books to page 367. Now, this is the first problem right here, okay? We're solving for x. We're going to cross multiply. 3 times 16 is 48. 4 times x is 4x. Set them equal. And now divide both sides by 4. And when we do that, we will get 12. Sorry about that. My cell phone is going off. When we do that, divide both sides by 4, we will get x equals 12. Okay? All right, let's continue on. Number 2. We're solving for y. So we have 2 fractions that are equal. We know we can cross multiply. This should give us 200. 5 times y is 5y. Divide both sides by 5, and you will get 44y. Okay? All right, let's take a look at number 3. Now, this was the one that gave a lot of you trouble. Now, watch carefully. When I cross multiply like this, I not only multiply the 2 times the z, I must also multiply the 2 times the 3. So 2 times z is 2z, 2 times 3 is 6, equals 66. And where did I get 66? 6 times 11. Now we have a good old linear equation we're going to solve. So we're going to bring this 6 over and make it a -6. And now the 6 is gone. So I'm left with 2z equals 60. Now divide both sides by 2 and z equals 30. Okay, so that's how you were supposed to do that one, and a lot of you missed that one, so I hope you're taking some notes there and seeing what to do. You see, there are some students that do homework and listen to math videos just to get them over, and there are some students that do homework and listen to math videos to actually learn. Let me get a drink here. And that's really where you need to be. You should be doing these videos and doing your homework to learn, not just to, let's just get this dumb stuff done and go on, okay? Don't be like that, okay? Your education is very, very, very important. Now, these next three, 1, 2, 3, you guys really struggled with. So please listen to me and please let me help you, okay? All right, here we go. Watch carefully. This side right here has 2 slashes and 1 slash, or 2 marks and 1 marks at the end. And this side right here has 2 marks, 2 marks, and 1 mark. So I know x goes with 15. So I'm going to put right here 15 over x equals, now see this side right here? This side right here, this 18, has 2 marks and 3 marks. So which side up here has 2 marks and 3 marks? This side right here. This side right here has 2 marks and 3 marks. So 18 would go with 27. So I would say 27 over 18. By the way, notice I did not put 18 over 27. If I put 15 over x, then it has to be 27 over 18. Okay? Now the only side left up here is 18. And the only side left down here would be 12. So 18 goes over 12. So there, I just wrote out all three of my proportions, all three of my ratios. And now look, I don't care if you use these two to solve for x, or if you use 15 over x equals 18 over 12. I really don't care. You'll get the same answer either way. Please just trust me. You'll get the same answer. Okay, so let's go ahead and do some cross multiplying here. 18 times x is 18x, and 15 times 12 is 180. And then divide both sides by 18 and x equals 10. So there you found the length of the missing side right here. That side right there is 10. Boy, I hope this is making sense, students. I really do, okay? Let's try another one. All right. Now, here it's obvious we have a rectangle, 4 right angles, and it's obvious we have a rectangle, 4 right angles. And it's obvious that the shorter side will correspond to the shorter side. So 6 would go over 3 equals, well, the longer side is going to correspond with the longer side, so 10 over y. If we cross multiply, 3 times 10 is 30. Cross multiply, 6 times y is 6y. Divide both sides by 30, or divide both sides by 6, excuse me, and your answer will be 5. Okay, your answer is 5. And then lastly, let me really quick grab a drink here. Okay, I'm going to get rid of some stuff here and get us a little space, so give me a second to do that, please. And then slide this over. All right, here we go. Now, okay, match up corresponding side with corresponding side. I notice this 8 right here has, this side right here has 2 marks and a right angle. So, which side over here has 2 marks and a right angle? Z, right here, this side right here. It has 2 marks and a right angle, so I know that 8 is going to correspond with Z. So I'm going to put 8 over Z. I'm going to cross those off so I know that I've used them. Okay, now this side right here with the 6 has a right angle and a single mark. So which side over here has a right angle and a single mark? Well, this side right here, see it? It's got a right angle here, and it's got 1 mark here. So 6 corresponds with 15. So I'm going to put 6 over 15. I'm going to cross off the 6. And the reason I'm crossing those sides off is now I can see the last side here has to correspond with this side here. So equals 10 over 25. Now look, I don't care if you match up this fraction or this ratio with this one over here and solve for z that way, or if you match up this fraction here with this fraction, it doesn't matter. And that's the route I'm going to go. I'm just going to take this and get rid of it so it's not in our way. And now I'm going to simply use this to solve for z. So z times 6 is 6z. 8 times 15 is 120. And now we're going to divide both sides by 6, and z equals 20. Students, I love y'all. I would not want to embarrass you for $1 million. Well, maybe for $1 million. I'm just kidding. I wouldn't want to embarrass you for $1 million, but you got to know how to do this, okay? I'm not mad. I guess I'm a little perturbed. I've been over it and over it and over it, and there is not one of you who is not intelligent enough to look and say, oh, this side here has 1 mark and a right angle, and this side down here has 1 mark and a right angle, so this side goes with this side. Any of you can draw up those proportions, those ratios, and set them equal and make proportions and then solve. It's just not that hard, okay? All right, here we go. Let's go through a quick, snazzy, like that word, snazzy review. Are you ready? You don't have to take notes on this. I'm going to go really fast, and there's no need to take notes. All right, here we go. Don't forget that similar polygons have congruent sides. No. Congruent angles and congruent sides? No. Proportional sides. Angles are congruent, sides are proportional if a polygon is what? Similar. Similar, and here's a picture of it. Notice how this angle is congruent to this angle, this angle to this angle, this angle to this angle, and this angle to this angle. All of the angles are congruent. And see this side here, 4 and 8. If you put 4 over 8, and you put 2 over 4, and you put 5 over 10, and if you put 5 over 10, and you set them all equal, and you reduced all of them, you would get 1/2 equals 1/2 equals 1/2 equals 1/2. Okay, so these two polygons are similar. Congruent angles, proportional sides. We've learned 3 quick ways to test or prove, however you want to say it, triangles are similar. All right, so here we go. One way is angle. If I have an angle in this triangle congruent to an angle in another triangle, and an angle in this triangle congruent to another angle in this triangle, then I know for sure, without knowing any other information, I know for sure these two triangles are similar. They might be congruent. We just don't know for sure about that. We know for sure they're similar. All right, the side similarity theorem. Remember, if all 3 sides of one triangle are proportional to all 3 sides over here, then we know the 2 triangles are similar. So real quick, I would say 6 over 10 equals 9 over 15 equals 12 over 20. And if you reduce all of these, you will get 3/5, 3/5, and 3/5. Okay, I'm not sure why I put a 4. 3/5. So all 3 sides in this triangle are proportional to all of its corresponding sides in this triangle. So I know, without needing any more information, I know for sure these 2 triangles are similar. They might be congruent. We don't know. We know for sure they're similar. And then we learn the side angle side similarity theorem, and that is if you have a side and then an angle and then a side. So 2 sides with an angle in between. And then the other triangle, we also have a side, an angle in between, and a side like this. Then we might have side angle side. Let's check and see. The angles have to be congruent, and they are, and the sides have to be proportional. So 2 goes with 4. 2 over 4 equals 3 corresponds with 6. 3 over 6. 1/2 equals 1/2. So are the angles congruent? Yes, they are. Are the sides proportional? Yes, they are. So I know for sure these two triangles are similar. They might be congruent. I don't know, but I know for sure they're similar. All right, let me get a drink real quick while you're writing that down. We're going to look today, this is where we start taking notes now. We're going to look today at segments in the interior of a triangle. Segments in the interior of a triangle. All right, the date today, if you want to write that down, is the 21st, so 01 21 14. I encourage you to always write that down. And here we go. We're going to be looking today at 3 different theorems. 3. These 3 different theorems are going to deal with a segment that is inside the triangle. So we will be looking at 3 different theorems today dealing with a segment that is inside a triangle. Like here's a triangle, and then here's a segment like this. And that's what we're going to look at today. All right? I'd like you to copy this down. Remember, I go fast. You're going to have to pause the video. That's fine. Theorem 7.4. Yes, you'll need to know this on your test this Friday, by the way. Yes. The triangle proportionality theorem. If a line, that should be is right there, is. If a line is parallel to one side of a triangle, oh, I'm sorry. Would you please forgive me for making a mistake? There should not be an is there, and I'm sorry about that. All right, here we go. If a line parallel to one side of a triangle intersects the other 2 sides, then it divides the 2 sides proportionally. Let me say that again. If a line parallel to one side of a triangle intersects the other 2 sides, then it divides the 2 sides proportionally. Now, guys, go ahead and copy this down, and then copy this down in your notes also. A picture is worth 1,000 words. We know that. So let me show you. A lot of students read this, and you are so normal. If you read this and you're like, what? That's fine. It's my job as a teacher to explain this to you. Let me show you what it means, okay? First of all, if a line parallel to one side of a triangle intersects the other 2 sides. So what it's saying is this. Are you ready? Here's Earhart translation. We got a triangle right here. Everybody see that triangle? There's that triangle. And inside that triangle, we have this segment. Now notice this segment, first of all, intersects 2 sides of the triangle. That's very important. Okay? We can all see that, can't we? This segment right here, segment BD, intersects the triangle here, and it intersects the triangle here. We can all see that. And also, we can also see that this line right here, this segment inside the triangle, is parallel. See the parallel symbols? Is parallel to this side of the triangle. So it looks like all of our if stuff has been satisfied. If a line is parallel to one side of a triangle, intersects the other 2 sides, then it divides the 2 sides proportionally. What that means is simply this. It means if I put, oh, I don't know, let's make this, let's see. If I put a a 2, let's see, a 3 here. No, that won't work. If I put a 4 here and a 6 here, go ahead and write that down, please, and a 2 here and a 3 here. Now watch what happens. Notice how if I take this side and put it over this side, watch, I get 4 over 6, and if I put this side over this side, take some good notes on this, I get 2/3. And if I reduce 4 6 and I reduce 2/3, which can't be reduced, notice those 2 fractions are equal. So I can put this side over this side equals this side over this side. Okay? Or, let me show you something else you need to see. Now watch this. Or there's something else you can do. You need to know this. It can also be done another way. Watch this. You can put this segment over this segment, and that would be 4 over 2 equals, but this segment over this segment, 6 over 3. And if you reduce both of those, you'll get the same fraction. You'll get 2 over 1 equals 2 over 1. And that's all that that theorem is saying. That's it. That's all that it's saying, okay? I mean, it's really not that bad. It's just simply saying that if, let me continue erasing this here, if this segment right here that I'm circling right here, if this segment intersects two sides of the triangle, which it does, and if it's parallel to the third side, which it is, then we know that we have, I'm going to kind of use a paraphrase here, we know that we have all kinds of proportions all over the place. You can say this over this equals this over this. Or if you don't like that, you can say this over this equals this over this. It doesn't matter. So that's what that theorem is stating. Okay? Copy this down. Theorem 7.5. If a line divides two sides of a triangle proportionally, then the line is parallel. If a line divides two sides of a triangle proportionally, then it's parallel to the third side. Can I tell you what this is? It's the opposite, guys. Look, let's go back a page. Over here it was saying if a line drawn in the triangle is parallel, then it divides the sides proportionally. Now this is the converse. Now it's saying if the sides are divided proportionally, then this line is what? This line is parallel to this line. So let's take a look at this. Do I have a triangle? Now watch this. Yes or no? Do I have a triangle right here? I just highlighted for you. Yes, I do. Do I have a segment inside of the triangle? Yes, I do. Does that segment divide these two sides up proportionally? I don't know. Let's find out. Remember, we can do it two different ways. We can say 3 over 4 equals 6 over 8. That's one way to do it. 3 over 4 equals 6 over 8. Or another way to do it is to say 3 over 6 equals 4 over 8. That's another way to do it. Either way is acceptable. I have no preference. I'll probably do it both ways throughout the class period, just so you can see it both ways. Well, let's reduce these fractions and see if we get the same thing out. Because if we get the same thing out, then we know that we have these sides divided proportionally. And if they're divided proportionally, then I know this third side is what? Parallel. All right. So if I reduce 3/4, I get 3/4. If I reduce 6/8, I get 3/4. That's good enough. I'm done. You don't have to check this one. Now I'm going to check it just to show you it works, but that's it. I'm good. 3/4 equals 3/4. I'm going to go ahead and do this one too, just for the fun of it. 1/2 equals 1/2. There you go. So is this line drawn in such a way that it divides these sides up proportionally? Yes. So what do I know about this side and this side, or those two segments? I know they're parallel. So yes, they're parallel. And that's what Theorem 7.5 says. So Theorem 7.4 and Theorem 7.5 are converses of each other. Theorem 7.4 says if a line is drawn inside a triangle and it's parallel to the third side, then it divides these other two sides up proportionally. And then over here, Theorem 7.5 says if a line is drawn inside of a triangle in such a way that it divides these two sides proportionally, then this line is parallel. It's just the converse of the other. And then the last one, and then we're going to do a bunch of problems. And remember, there's no homework tonight, so it's okay. All right, and tomorrow, I think you'll finish the homework assignment before class is over tomorrow, okay? Let me get a quick drink here. Let's take a look at Theorem 7.6, the mid-segment theorem. The segment connecting the midpoints of two sides of a triangle is parallel to the third side, and it's half as long. Let me read that again, and then we'll talk about it, and I'll give you some pictures down here so you understand what it's saying. Theorem 7.6 is called the mid-segment theorem. The segment connecting the midpoints of two sides of a triangle is parallel to the third side, and it's something else. It's half as long. All right, now let's talk about this for a second. Now, watch this carefully, and I'm not bragging, but I'll explain this to you. Watch carefully. Here we go. All right, do we have a triangle here? I'm not treating you like first graders. I'm just asking you a question. Do we have a triangle here? Yes, we do. Do we have a segment inside the triangle? Yes, we do. Now, notice the segment does something very interesting. Notice that this point here is right in the middle of the side. See, do you see how there's one mark here and there's one mark here? What that means is, let's pretend that we have a length of 5 from here to here. That means we also have a length of 5 also down here. And over here on the other side, let's just pretend, we don't know this, but let's pretend we have a length of 6. Then this segment down here is also a length of 6. Do you see that okay? So this segment drawn inside the triangle is a special segment. It's drawn in such a way that this point right here is the what? Do you see it up here? It's the midpoint. And this point right here is the what? It's the midpoint. Do you remember what a midpoint is? A midpoint is a point that's right in the middle of a segment. A midpoint is a point that's right in the middle of a segment. So see this segment right here? This point is right in the middle. See this segment right here? This point is right in the middle. All right, so this segment right here is connecting two midpoints. This is a midpoint, this is a midpoint, and this segment is connecting the two midpoints. So what it says is this: the segment connecting the midpoints of two sides of a triangle is. Now this segment right here, do you see it? It's two things. As long as this line is drawn here in such a way that this segment is congruent to this segment and this segment is congruent to this segment. As long as that happens, we know two things about this segment. We know two things. Here they are. Number one, it's parallel to the third side. So I can go ahead and say this is parallel to this. And I also know what else? It's half as long. So let's pretend this side down here has a length of 10. Then this side up here has a length of what? 5. Or let's pretend that this side up here is a length of 8, or this segment. Then this side down here has a length of what? 16. All right? It's going to be half as long. So you can say it one of two different ways. You can say this shorter segment is half as long as this segment down here, or you can say this longer segment is twice as big as the segment up here. So one more time, and then we're moving on. It's simply saying this: if you have a triangle and a line drawn inside the triangle in such a way that this segment's congruent to this segment and this segment's congruent to this segment, when that happens, then you know two things. You know this side up here, the length of this side right here, is going to be half as long as this side down here. You know that. And then secondly, you know that this segment here is parallel to this segment here. All right, let me grab a quick drink. We're going to jump into a bunch of problems. Okay, please copy this in your notes and let's get started. Copy this down. You might have to pause the video. I'm going to move on. Solve for x. All right, here we go. We're going to use this theorem right here to help us solve for x. If a line parallel to one side of a triangle intersects the other two sides, it divides it proportionally. So in other words, if I have a triangle, which I do, and I have a line drawn on the inside, which I do, that's parallel to the third side, then I know all of these sides here are proportional. Okay, so if I know all of these segments here are proportional, I can say 4 over x equals 8 over 12, or I can say 4 over 8 equals x over 12. Students, it just doesn't matter. Okay, it just doesn't matter. And so I'm going to go ahead and use this one because I feel like it no certain reason. 8 times x is 8x. 4 times 12 is 48. Divide both sides by 8 and x equals 6. So there, we found the length of CE. The length of CE is 6. All right, let's try this again. Using that same theorem, here we go. Notice how I have a really big triangle like this, and inside that triangle I have a segment. And notice that that segment is parallel to this side right here. So that means all of these sides are proportional. So I want us to solve for x. And here's x right here. Here's the length of x right there. So I want us to, you can do it one of two ways. 20 over 10. Now be careful. 20 over 10 equals 22 over x. Or you could say 20 over 22 equals 10 over x. It really doesn't matter, students, okay? I'm going to use this one over here. 10 times 22 is 220. 20 times x is 20x. Divide both sides by 20, and 11 equals x. 11. Okay? All right, let's continue on. Whenever you have a triangle and a segment drawn on the inside is parallel to the third side, then all of these segments are going to be proportional, always. All right, this will be a challenge for you. I want to see if you guys can figure this one out. This one's going to be really, really, really interesting. We'll see if you can get this. This one's going to be difficult for you. And hang in there and work hard. Okay, we can get this. All right, now, first of all, do I have a big triangle here? Yes, I do. Do I have a segment inside the triangle? Yes, that segment is right here. Is that segment parallel to this side here? Yes, parallel, definitely. So I know that all of my segments here are going to be proportional. Now, this is going to be really, really hard to see, and I doubt if I'll give you one like this in the test, but I might. You never know, so pay attention, okay? Would you just pretend for a second that this is the number 8 right here? If that was 8, and you know the whole length here is 20, how would you find the length from S to T? Would you not take 20 minus 8? You would say 20 minus 8 equals 12. Would you not? If the whole length is 20 and this much is 8, you would say 20 minus 8 is 12, correct? Okay, well, let's do the same thing. Even though it's a Y, the segment from here to here, just like when it was an 8 right here, you said 20 minus what? 20 minus 8? Well, just because it's not an 8, don't worry about it. It's 20 minus what? Y. I mean, just because it's a Y doesn't matter. If this was an 8, you would have said what? 20 minus 8, right? Isn't that what you would have done? Sure you would have. Well, same thing. Don't freak out because it's a letter. It's no big deal. So because this is a Y, then that means the length from S to T is 20 minus Y. And now with that, I'm ready to solve this. I can do it different ways. I can say 9 over 3 equals 20 minus Y over Y. That's one way. Or I could say 3 over Y equals 9 over 20 minus Y. And either way, you'll get the same answer. I'm going to go ahead and use this one over here. 9 times Y would be 9Y. Now be careful here. When you multiply these two, this cross multiplication, the 3 gets multiplied by the 20, but it also gets multiplied by the negative Y. So 3 times 20 would be 60, and 3 times negative Y would be negative 3Y. Okay? Now again, Haley, I've never had you in Algebra 1, and Martin, I haven't had you either, but I know the rest of you, Jason, Jake, and Azu, I had you in Bridge Math. We know how to solve linear equations like this. We want to get all of our y's on one side. So I'm going to bring this negative 3y over, and when I bring it over, it becomes a positive 3y. So now it's gone, and I'm left with, well, 9y plus 3y is 12y. 12y equals what? 60. Divide both sides by 12, and y equals 5. And of course, Haley and Martin, I hope you guys know how to do that. It's a pretty simple Algebra 1 equation. Okay, there we go. So you found what y is. Sorry about that. Let's go back a page. You found what y is. Y is 5, just like that. Pretty tough thinking problem. It's pretty good. All right, let's apply our second theorem. All right, we're going to use this theorem down here. If a line divides two sides of a triangle proportionally, then it's parallel. Okay. Our segments MN, here's MN, and GH, here's GH, are they parallel? Yes or no? Well, let's find out. Remember this, what we're going to have to do is see if these sides are proportional. Now you can do 56 over 21 equals 48 over 16, or you can do 56 over 48 equals 21 over 16. It doesn't matter. I have no certain reason. I'm just going to say 56 over 21 equals 48 over 16. Now let's reduce these and let's see if the two sides are proportional. Okay, 7 goes into both of these. 7 goes into 56 8 times, and 7 goes into 21 3 times. Over here, 16 goes into both of these. 16 goes into 48 3 times, and 16 goes into 16 once. Is 8 over 3 equal to 3 over 1? No. So are these segments proportional? No. So are these two segments here parallel? Is MN parallel to GH? No, they are not. No. That's it. That's all you're doing. You're just running a test and telling me if those two lines are parallel. Okay, let's try another one. Okay, you can work ahead or watch me. Our segments RQ, this segment here, and TS parallel? Well, let's see. I mean, we have a triangle. We have a segment drawn on the inside. So that means these outside segments here should be proportional. Well, let's see. Let's put 21 over 23, because I just feel like it, no certain reason, equals 15 over 17. You could have also said 21 over 15 equals 23 over 17, or 15 over 21 equals 17 over 20. It doesn't matter, okay? All right, well, I chose 21 over 15 equals 23 over 17. Well, you can't reduce this. Nothing goes into it. You can't reduce this. Nothing goes into both numbers evenly. Are these two fractions equal? No, they are not. So if those two fractions are not equal, then these outside segments here are not proportional. And if they're not proportional, then this segment here and this segment here, they are not parallel. They are not parallel. All right. Okay, let's try another one. Here we go. All right. Are segments BE and CD parallel? Well, let's see. We have a triangle here. We have a segment inside a triangle. So if BE is parallel to CD, if they are, then that means these outside segments should be proportional. Now, notice from here, A, all the way down to C, it's 14. So that means BC right here must be what? 4, because from here to here is 10, and then from here to here would be 4, so 10 plus 4 is 14. All right, so here we go. Now let's see if these segments are proportional. We could do 10 over 15, that works, equals 4 over 6. Now there's more ways. We could have said 10 over 4 equals 15 over 6, but I decided to go 10 over 15 equals 4 over 6. Well, 5 goes into 10 and 15, and it becomes 2/3. 2 goes into 4 and 6, and it becomes 2/3. Does 2/3 equal 2/3? Finally, yes. So this side here, or this segment here, is parallel to this segment here. Okay? So there we go, moving right along. We've just worked with theorem 7.5, the second one that we learned. Let me grab a quick drink here. Okay, here we go. I really don't like these parallel symbols here. That has nothing to do with it whatsoever, to be honest with you. There we go. And I do try to be honest with my students on Tuesdays. No other day. Just kidding. All right, there we go. All right, what is the length of segment QS? Well, we looked at a third theorem today. It said this: the segment connecting the midpoints of a triangle like this on the inside is parallel, and it's half the third side. Now I have a question for you. Do I have a big triangle here? Yes. Do I have a segment drawn on the inside that connects two sides? Yes. Is this segment here congruent to this segment here? Yes. Is this segment here, RS, congruent to segment ST? Yes. When that happens, then I know this segment here is always half of this segment here. So if this is 10, then the length of segment QS would be 5. Pretty simple. But always look to check and make sure you have a triangle with a segment inside the triangle drawn in such a way that this segment's congruent to this segment and this segment's congruent to this segment. Let's take a look at one more problem and then we'll be finished. All right, last one. All right, here we go. Now, they want us to find the value of P. Now, I have a question for you. Do I have a triangle here? Yes. Do I have a segment drawn inside the triangle that's connecting two sides? Yes. Is this segment congruent to this segment? Yes. Is this segment congruent to this segment? Yes. Then that means this segment inside the triangle right here, P, is half of this. So P would equal 8. Now hopefully you were able to finish this video in class. I hope that you were, okay? I have not checked to see if I have this homework video, if it's working from last year, and you do not have to work on this. In fact, I encourage you not to, because excuse me, sorry, that just gives you free time in class to not do anything, and I don't really care for that, but I will give it to you in case you want to get a little head start. But I want to give a little disclaimer. The video is not loaded yet. Do understand that. Now when it's loaded, I'll go over all this tomorrow in a video, but What I wanted to say is this. I know the assignment I gave last year was this right here. I've tacked this on right here. And I'm not sure yet if I'm going to make you guys do that or not. It all depends on whether or not I have time to do a little additional video to go with the one from last year. So I want to give a little heads up right now. If you decide to work ahead, which I really don't want you doing a whole lot of that because you have the whole class hour tomorrow to work on it, okay? But if you do, those and then find out you don't have to, don't be upset at me. I'm not sure yet if I'm going to include this part here or not. I know for sure you're going to do these tomorrow, and probably a pretty good chance you'll do these also, okay? So there's your homework for tomorrow. We're going to work on that in class. You do not have to work on it now. You do not have to work on it tonight. Oh, and I'm sorry, I almost forgot, but I didn't. So that's how it goes, 3 times. All of your theorems 3 times, guys. I'm not going to hedge on that. I'm not going to stop. You need to do that. So please write your theorems 3 times each along with this, and all of that will be done in class tomorrow, and you will turn it in on Thursday. Now I know tomorrow's Wednesday, but I'm sure most of you will get it done in class. Okay? Have a good day. Call or email if you have any questions.